nandito na naman tayo for our session on math facts for pre-calculus. So to start with, let's first acknowledge our writers for week 2 of the math facts for pre-calculus. We have Ma'am Catherine Estrada, and as you can see, based on our previous math facts, medyo nag-iba yung layout niya, no? So meron na tayong graphic artist, si Sir Patrick. Ang layout artist natin is still the president of this MTA, Division of Iloilo Secondary Mathematics Teachers Association, Ma'am Krisha May Haruda, and of course our Division Quality Assurance, Dr. Kim Arsenia, Dr. Julio Villalon, and of course our Education Program Supervisor in Mathematics, Dr. Kim Arsenia, and the rest of the team from the Division Office of Iloilo, Schools Division of Iloilo. So let's start. For week 2, the focus of this lesson is about parabola. Okay, so for week 1, we had circles. This time, the conic sections that we will discuss is all about parabola. I think you're familiar with parabola, but the thing is, the parabola that you have encountered in junior high school are parabolas facing upward or facing downward only. But this time, um, in this course, you'll be encountering another set of parabola that is those parabolas facing or opening to the right and opening to the left. Okay, so these are the properties of the equation of the parabola. So your equation could be in one form. It could be in vertex form, and later on we will have the general form. So these are the properties of the type of parabola that you have. So if it's opening upward, this is the equation, and if it's opening downward, this is the equation. Both of these are parabolas whose vertices are at the origin. All right, so let's have an example. Okay, wait lang ha. Okay, sige. Now let's have example. Let's have the property here and this one here. Okay, so this is page 1. Medyo na confused ako kasi parang iba yung kasunod. Ito pala yung page 6. So let's proceed to page 2. So this is page 2. If your parabola is opening to the right or opening to the left, these are its standard forms. Okay, so just simply read your properties. Now let's proceed to the most important part, which is the exercises. So the type of parabola here is based on the opening. Okay, so if the opening is downward or upward, then you would say it is a vertical parabola. But if it's opening to the right or opening to the left, then it is a horizontal parabola. Okay, let's have exercise 1. Where is your exercise 1 here? She doesn't have an exercise 1. No, wala siya exercise 1. Am I correct? Here it is. So here is exercise number 1. So here is exercise number 1. So since this is opening upward, so it is a vertical parabola, right? And obviously, the vertex is at the origin, which is 0, 0. The opening is upward, and the focus is this point, okay? The focus is derived from the 4C value. Notice that in our properties, you have the 4C, Y. C is the C would be the units above the vertex, meaning the distance, the length of the distance from the vertex to the focus. That is the C value. All right. So if the C value here, if the 4C value rather is 8, meaning 4 times C equals 8, that means our C value is 2, correct? So notice on the graph that the distance from the vertex to the focus is 2 units. Therefore, the C value here is 2. Since there's a constant value 4, meaning 4 times 2 is 8. Okay, so the focus now is at is the point whose distance from the vertex is 2 units, meaning this is uh, 0, 2. Okay, so this point is 0, 2. A focus is a point, okay, but you get the point by getting first the distance from the vertex. Okay, since the parabola is facing upward, then the focus is above the vertex. Take note of that. Now, the directrix, on the other hand, is below the vertex. Okay, it's always below or behind the vertex. One property of the parabola is that the distance from the vertex to the focus is the same distance from the vertex to the directrix. So if the distance from the vertex to the focus is 2 units, 2 units is also the distance from the vertex to the directrix. So that's why you have this line here, which is 2 units below the vertex. So unlike your focus, your directrix is a line. Focus is a point. So to get the focus, you get the coordinates, which is 0, 2. But for a directrix, it should be a line crossing this axis, the y-axis, at 2, because the distance from the vertex to the directrix must be 2 units. You get that from the C value. So therefore, this line is the line whose equation is y equals 2. Y equals 2 because it is a horizontal line crossing the y-axis at 2. So y equals 2. Okay? Now, for axis of symmetry, the axis of symmetry is the line perpendicular to your directrix. Or, you can also describe the axis of symmetry as the line passing through the focus and the vertex. Okay, so your axis of symmetry could be described in 2 ways. It is a line perpendicular or having a 90-degree angle with the directrix. Or an axis of symmetry is a line crossing the vertex and the focus. Okay, so in this case, this line is our axis of symmetry, and it so happened that this line is also the y-axis. So therefore, the axis of symmetry is the y-axis, and the equation of the y-axis is x equals 0. X equals 0 because this line is crossing the x-axis at 0. Okay, I hope that's clear. All right, so let's proceed to example number 2. Exercise number 2. Okay, so the same procedure as exercise number 1. You just have to determine the type of parabola. So it's opening downward. So it's also a vertical parabola. The vertex is at 0, 0. Correct? The opening is downward. The focus is at this point. Okay? But this point is determined by getting or solving this value. So negative 6 is equal to 4c. So divide 4, divide negative 6 rather, and 4. So negative 6 divided by 4, right? Because negative 4c, or 4c rather, 4c is negative 6. So negative 6 divided by 4, that would be how much? 3 halves, right? Negative 1.5. Okay? So meaning to say the focus is at 0, negative 3 halves, or 0, negative 1.5. Why is it negative? Because your parabola is facing downward. Why it why is it facing downward to begin with? Because the given equation has a 4c negative, which is negative 6 in this case. All right, now that's your focus. For your directrix, the same distance, it's negative 1.5. So you count 1.5 units, okay, 1.5 units above. This time, the directrix is above the vertex because your parabola is facing downward. So it's here on top of the vertex. So it's 1.5 units from the vertex. So that means this is positive 1.5. So equation is y equals 1.5. And the axis of symmetry is still the same, the x-axis or the y-axis rather, the y-axis or x equals 0. Okay? So the same, just follow the pattern. For exercise number 3, where is exercise number 3? Okay, for exercise 3 and 4, these are horizontal parabolas, right? These are horizontal parabolas because they are facing to the right and the other one is facing to the left, facing or opening. Okay, another way of saying it is facing. Some books, some books would tell you it's opening upward, opening downward. Okay, now the same vertex is at the origin. The focus is based on this particular equation, 18. So that means 18 is equal to 4c. So that means 18 divided by 4 would be 9 halves, or 4.5. So you count 4.5 units to the right because the parabola is facing to the right. That you count 4.5 units from the vertex. You always count from the vertex when you want to determine your focus. And then 4.5 units again to the left for your directrix. This time, the axis of symmetry is the x-axis. So the equation for this would be y equals 0 because it's a line crossing the y-axis at 0. So y equals 0 is the equation of your x-axis. For the directrix, the equation is negative x equals negative 4.5. Why is it x equals negative 4.5? X because this line is crossing the x-axis at 4.5. Okay, so x equals negative 4.5 because it's on the negative x-axis. You could also say x equals negative 9 halves. You could also write that. If you don't want the decimal value, you can have the improper fraction. For example 4, the same thing. Example 4 or exercise 4. Okay, for exercise 4, you do the same thing. All right, so this is again a horizontal parabola whose vertex is at the origin. It's opening this time to the left. The focus is generated by solving negative 7 equals 4c. So c is negative 7 fourths. So it's negative, that's why it's facing to the left. So negative 7 fourths. This time the focus is at negative 7 fourths. 0, the point, negative 7 fourths is 0. 7 fourths is equivalent to 1 and 3 fourths. 1 and 3 fourths, that's why it's almost here. On the other hand, the directrix is at x equals 7 fourths because this line is the directrix crossing the x-axis at negative or positive 7/4. The axis of symmetry is again the x-axis. Okay, so I hope there's no problem for your math packs part A. Okay, let's proceed to part B. Okay, part B. For part B, the focus here is parabolas, or is a parabola whose vertex is not at the origin. Okay, so what if the vertex now is somewhere or anywhere on the Cartesian plane? Okay, the first part is easier because your vertex is at the origin, meaning at 0, 0. On the other hand, this one would be a little bit challenging because you have to count and be careful in counting your focus and identifying your vertex as well as the directrix. You have to be careful in identifying the coordinates of the point because your counting must be accurate. Okay, so just like your parabolas whose vertices are at the whose vertex rather is at the origin, we follow almost the same pattern as that of the first one. However, this time it's not just x squared, but it's x minus h squared. It's not just 4cy, but it's 4c times the quantity y minus k. Why is that so? What are these values for? These h and k values are the coordinates of your vertex. Okay, these are the coordinates of your vertex. So h is the x coordinate, k is the y coordinate. So putting them together, you get the vertex of the parabola. So if it's opening upward or downwards, it's still a vertical parabola. Okay, how do we get the focus this time? So to get the focus, you still generate it from the 4c value. Okay, you still get it from the 4c value. The c value is the distance, still the distance from the vertex to the focus, or the distance from the vertex to the directrix. They are equal. These two have equal distances. Okay, so let's have exercise 1. Okay, let's look for exercise 1. Here it is. Okay, now this is the given equation. So the first thing that you can determine actually is the type of the parabola. Okay, so how do you know that it's facing upward? When it starts with x and then the one being squared is the x variable. It's facing up or facing down. All right, that's the hint. So if the one being squared is the x variable or the quantity with the x variable, then it is facing upward or downward. It's upward when this value, the 4c value, is positive. It's downward when the 4c value is negative. Okay, so positive upward, negative downward. If it starts with x squared or x quantity squared, it's up or down. Okay, now the vertex. For the vertex, you look for the h and k value. Remember, the h is always together with x and the k is together with y. So this is x minus h. Therefore, the x coordinate of the vertex is at 3. This is y minus k, meaning this is k, so the vertex is at 3, 1, right? 3, 1. So 3, 1. Correct. All right, the focus this time. For the focus, you need the same thing. You need to solve for the c value. Since 4c equals 8, therefore c is how much? 4c equals 8. Therefore, 8 over 4 is 2, correct? So the distance from the vertex to the focus is 2 units. So you count 2 units from the vertex at 3, 1. So this is 3. You count 2 units upward. This is a 3, 1. So 1, then 2, then 3. Okay? So meaning the y-coordinate for this one would be 3. So the x-coordinate would be 3 also. So the coordinates of the focus, therefore, would be at 3, 3. Follow? Okay. Why is it 3, 3? Because your x-coordinate for the vertex is at 3, right? So since the vertex and the focus are collinear, meaning they are on the same line, okay, so the x-coordinate of the focus would also be 3. The only difference is that since it's 2 units above the vertex, so you have to count 2 units from 1 because this is 1 unit right here because of this value. Okay, so 1 unit, then 2 units above it would be 3. So the focus would be 3, 3. Okay, directrix, the same thing. You have to count 2 units, but this time it's below. So you count 2 units below. So this would be 1, 2. Okay, I think the scaling of this graph is different. No? So this would be 1 unit, then 2 units. All right. So I think that 2 units is here. So this is 2 units. Therefore, the same thing. This is the point right here. But since the directrix is a line, we're not looking for a point. So where is this line crossing now? Since it contains the point 3, -1, right? So the directrix would be y equals -1. It is a line crossing the y-axis at 1. So the directrix is a line whose equation is y equals -1. Okay? All right. Axis of symmetry. For the axis of symmetry, we just look for this line, the line where the focus and the vertex coincide or lie, right? Okay, so focus and vertices are and the vertex are lying on this line. So since this line is crossing the x-axis at 3, because your h value is 3, so x equals 3 would be the axis of symmetry. Okay? Okay, next. Exercise number 2. Where is exercise number 2? Okay, this one. Exercise number 2. The equation is x minus 1 squared equals -12 times the quantity y plus 2. So obviously this will tell you -12 is the value of 4c. So since it's negative, it's opening downward. All right? So the type of parabola, if it's downward, is it's vertical. The vertex can be found from this value. So h, k. So h is 1 and k would be what? Because this is supposed to be y minus k. But since in this case it's plus, meaning this is y minus -k. That's why it becomes plus. So therefore, the k value is -2. So the vertex is at 1, -2. That's why it's 1, -2. Okay. The opening is downward. The focus this time, we get the focus from this value. So 4c equals -12. -12 divided by 4, that would be 3. 3 units, okay? The negative only indicates that you're supposed to count downwards, okay? But distance is always positive. So 3 for the c value. So you count, since this is negative, you count downwards. So 1 unit, 2 unit, 3 units. So since you started from -2, so you count 3 units. So this is -2, -3, -4, -5. Okay, so the y coordinate here is -5. The x coordinate here is 1, same as your h value. So the focus is at 1, -5. Okay, for the directrix, again, since this is opening downward, it's above the vertex. So you count still the same 3 units. So from -2, you count 3 units. So -2, it's going backwards because you're going up. So -2, -1, 0, 1. Therefore, this line is crossing the y-axis at 1. Y equals 1 is your directrix. For the axis of symmetry, this is the line crossing your vertex and focus. And this line is crossing at x equals 1 because your h is 1. So the axis of symmetry is x equals 1. Okay, are you good? I hope that's clear. Then let's have exercise 3. Where is exercise 3? Okay, here it is, exercise 3. We're almost done. For exercise 3, this time, exercise 3 and 4, these are examples of parabolas facing left and right. Okay, now, how would you differentiate those from from those parabolas facing up or down? This time, the one being squared is y, is the y variable. So you start with the y variable. Okay, so the standard form is always this in this way. You start with the one being squared followed by the one that's not. Okay, but sometimes pwede ma-interchange. Okay, pwede din namang ma-interchange. But you always have to look for the one being squared. If it's y, then it's either facing left or right. But if this one is squared, then I mean this one is x, then it's either up or down. Okay, now the type of parabola, if it's left or right, is horizontal. So this is a horizontal parabola. Okay, again, for the vertex, you always have to look for HK. Again, H is together with X and K is together with Y. So don't get confused. It's not that what the one being presented first is your H and the one presented second is the K. No, the H is together with X and K is together with Y. So this time, our vertex is 2, 3. So 2, 3. All right. The opening is obviously at the right because your C value here, I mean the 4C value is positive. So 4C value is 10. So 10 divided by 4, that would be 5 halves, right? 5 halves or 2.5. Okay, so 2.5. Now, the focus would be, okay, so you count 2.5 units from this vertex. So this time, we're counting to the right because the parabola is facing right. So how many units to the right? It's 10 over 4 or 5 halves or 2.5. So 1, 2, 2.5. So what would be the coordinates of this point? Since you started with 2, this is 2, right? Because h is 2. So 2, 3, 4.5. So the focus would be at 4.5. Then the k value, I mean the y coordinate for the focus would be the same as that of the equation, which is 3. So this is 4.53. The focus is 4.53 or 9 halves 3. You can also say that. For the directrix, the same thing. You count 2.5 units this time to the left behind the vertex. So 1, 2.5. So this is 2. So 3, this is at x equals 2. So this becomes 1, 0, and this is 1 half. Therefore, the directrix is this line crossing the x-axis at 1 half. So x equals 1 half is your directrix. And for the axis of symmetry, this is the line crossing your vertex at 2, 3. So y is 3. So this is your axis of symmetry. Y equals 3. Okay? Very easy. I know you can do it. And the last example for 2B, part B, exercise 4. The same thing. This time it's facing to the left. So this is a horizontal rather, horizontal parabola. And the vertex is at 1, -1. Why -1? Because this is y minus k supposed to be. So this would be y minus negative k, which is -1. Okay, so this is your vertex right here. It's 1, -1. So it's so little. Oh, it's so little. Never mind. Okay, so just imagine that this is 1, very tiny, because the scaling is by 10, no? 10, 20. Okay. Now, opening the parabola, of course, obviously it's to the left. The focus would be generated from -24. So -24 divided by 4 is 6. So 6 units, you count 6 units from the vertex going to the left. So 1, 2, 3, 4. How do we count this? 1, 2, 3, 4, 5, 6. Medyo malayo ang 6 niya. Okay? So, 6 units. You started with 1. So, 1. So, maisol ka 6 units. You're going backwards 6 units. So, how much would that be? So, this is 0, -1, -2, -3, -4, -5. So this would be -5 for the x coordinate of the focus. And since it's aligned with the vertex, so it will follow the y coordinate of your vertex, which is -1. So therefore, the focus is at -5, -1. That this point is at -5, -1. Okay, for the directrix, the same thing. You count 6 units, this time to the right. So you started with 1, then you end up with 6 units after 1 is 7. Therefore, the directrix is the line crossing x equals 7. Okay, and for the axis of symmetry, you simply follow the, the y coordinate of the vertex, which is 1. Y equals -1. Okay. Let's proceed to part C, the last part. I know this one is a bit more challenging than the other two parts, but I know you can do it. Okay, so for part C, we are now doing the general form. Okay, the general form. The other two parts, the other two discussion is about standard forms or vertex form. Okay, so one way of calling these forms are vertex form, or because you can directly see the vertex of the parabola, or sometimes these are referred to as the standard forms. Okay, the standard form can be rewritten and expanded into a general form. Okay, so let's see if there are examples of general form. Okay, so this time the equations are not given in vertex form, so you have to rewrite it in such a way that it becomes the standard form. Okay, the standard form of the equation of a parabola with vertex hk and the vertical axis of symmetry is vertical axis of symmetry. Okay, where a, b, and c are real numbers, meaning the axis of symmetry is a vertical line. Okay, but if it has a horizontal axis of symmetry, this is the um, standard form. Okay, so uh, she has a different way of writing the standard form. Okay, sige. So let's consider her example. So this would be the standard forms in here. So following the equations of parabola in standard form, we have this. Okay, so given letter A, you have, let's rewrite this. What she wants to tell you is that you have to rewrite this in this form. Okay, in this form. So what we'll need to do is to simply expand this one because it has x plus 5 quantity squared. So simply expand this one and rewrite, combine like terms. So this is now the standard form, and this would be um, a different form. Okay, it's not vertex form either, right? Okay, for for this part now, for this part, page 2, okay, page 2. So 6y squared minus 3x plus 12y equals 18. So you simply have to rewrite this here on that way. And then since the standard form is x equals ay squared, so we what we want is an equation that starts with x, and the rest would be here. So we have to eliminate, we have to get rid of the coefficient of -3, okay, and then transpose transpose 6y squared on the other side, and 12y also, leaving 3x on the left side, and then getting rid of this by dividing all by 3 to get the standard form. The same thing for letter C. Okay, so just do the same thing for A, B, and C. Okay, so the same process with letter A a while ago shown to you, letter B, the same thing, exactly the same thing. Okay, let's proceed to page 3. Page 3. On the other hand, page 3, from standard form, we would want it to be in vertex form. Okay? Sige. So if it's in vertex form or in other forms, you could rewrite it to standard form. And at the same time, if it's in standard form or another form, it could be written also in vertex form. Okay? So that would be doing this way. All right? So for example, this one. What we want, what we want is an equation that has a perfect square binomial. Okay, a binomial that is being squared. So all you need to do is to regroup the given terms. Okay, regroup them. Since this one starts with y squared, this is grouped together with this equation, with this term here, 10y. So you group y squared and 10y, then transpose this or move this on the other side together with 10. Okay, so now you have y squared plus 10y equals 5x plus 10. This becomes positive because it came from negative. Transposing it by addition property of equality, it becomes 5x. All right, 10 remains positive 10. That's why it's plus 10. Now, where did we get 25 from? Since we want it to be in vertex form, we want it to be a perfect square trinomial. So y squared plus 10y plus something to become a perfect square trinomial. Okay, so to do that, divide 10 by 2 and then square it. 10 divided by 2 is 5. 5 squared is 25. That's why you got 25 here. All right, y squared plus 10y plus 25. Since this is an equation and you have added 25 on the left side, you have to do the same thing on the right side. So plus 25 here, plus 25 here. Now, since this is already a perfect square trinomial, okay, the factors would be y plus 5 squared, because y plus 5 squared would be y squared plus 10y plus 25. And then adding 10 and 25, you get 35. Factor out 5. The common factor is 5. So 5 times the quantity x plus 7. So from this equation, it becomes the vertex form. Okay, I hope that's clear. Okay, how about this one? Okay, very similar to your exercise here. This one. Hmm. The same thing. You regroup those with the same variables. So since you have x squared here, you have 4x, this means you have to group these two. Okay, so remember the vertex form has the terms that are being squared placed on the on the left side. Those that are not squared are on the left are on the right side. So the ones that are squared are on the left, the ones that are not are on the right. So x squared is on the left side, so it will remain here. 4x is on the right side, meaning it's on the right side of the equal sign, so you move it together with x squared. So from positive, it becomes minus. Then you move y and minus 5 on the other side. So y is minus y becomes negative y, and then minus 5 becomes plus 5. And then do the same thing. This should be a perfect square trinomial. So to make this a perfect square trinomial, you should divide 4 by 2. 4 divided by 2, 4 divided by 4, 4 divided by 2 is 2. Square it, it's 4. You might ask, why do we always have to divide this by 2? Is it always 2? Yes, you have to divide it always with 2 because we're looking for the square, a perfect square trinomial. All right. So 2 squared is 4. That's why you get 4. That's why you get x squared minus 4x by copying this and then adding 4 to make it a perfect square trinomial. Again, since you have added 4 on the left side, you have to do the same on the right side. So now this is the perfect square trinomial to be factored as x minus 2 squared equals, then add 5 and 4 becomes 9. So why is this minus 9 now? Because you have factored out negative from y. So factoring out negative from y, this is plus 9. So factoring out a negative 1 from positive 9, you get negative of the quantity y minus 9. Okay, because if you will multiply this back, it will again become negative y plus 9. So therefore, the vertex form of this equation is this one. Okay, the same thing for letter B exercise. So just follow this pattern. Okay, then we have example 3. This time, you're not given the equation, not the vertex form, not the standard form, or any other form, but you're given properties. How will you write the equation of the parabola if you're just given properties like vertex and focus? Okay, so to do that, all you need to focus on is on the given form. Okay, given form. Since the given vertex is at 4, 3, and the focus is at 4, 8, meaning to say h is 4, k is 3. All right, meaning to say the parabola is opening upward because they have the same x coordinate, right? They have the same x coordinate, meaning this focus is above this vertex. It's opening upward. So if it's opening upward, then the pattern or the form, the vertex form that we will follow is this one. Opening upward, meaning 4c is positive, and the one being squared is x. Okay, so simply supply the values here. So this would be 4, because that's h, then 3 for k. Okay, now, where do we get our c value? So C value is the distance, again, the distance from the vertex to the focus. Since the vertex is at 4, 3, and the focus is above it at 4, 8, so from 3 to 8, that's 5 units, right? That's 5 units. Therefore, C is 5, because C is the distance from the vertex to the focus. So C is 5, 4 times 5 is 20. So the standard or vertex form, rather, the vertex form of the equation of the parabola whose vertex is at 4, 3 and whose focus is at 4, 8 is x minus 4 quantity squared equals 20 y minus 3. You can write it in such a way that it becomes standard form. If you want to, you can also do this here. Okay? This is the standard equation. This is the vertex form of the equation. Okay? How about if the given information or property is not focus but directrix, right? Directrix. So since directrix, the distance of the directrix from the vertex is the same distance as that of the focus to the vertex, you also have to count the same thing, just count. So since the directrix is y equals 7, okay, so y equals 7, meaning that's between the first quadrant and the second quadrant, right? So vertex is at negative 1, 5. So the vertex is at negative 1, 5. Imagine where that is. So negative 1, 5. And the directrix is above it, which is at 7. Meaning to say, the parabola is opening downward because your directrix is above it. Okay, so the distance from negative 1, 5 to 7 is 2 units. 5, 7. So 2 units. Therefore, C is 2. Since it's opening downward, it should be negative 4 times 2. So supplying the values of your h and k, h is negative 1, so that becomes x minus negative 1 becomes x plus 1 squared equals negative 4 times 2, y minus 5. So this is the vertex form. And then we expand the square, square this, expand the binomial, it becomes this, and simplify further, you get this equation. This is the standard equation. This is the vertex form. Okay? I hope this video helped you in answering the exercises. Okay? See you on our next one.